Hello everyone. Today we will see lecture number 6 from Design and Analysis of an Algorithm. And today our topic is how can we judge our algorithm, or it's also called as an operation of order of growth. What are the different operations of order of growth? Okay, so there are three operations of this order of growth. One is called as big O, second is called as big omega, and third one is called as big theta, and it is represented like this. Okay, so what are these operations? So in order to understand all of these, we consider that we represent, or we can take two functions in order to represent all these, or in order to understand all these. And let the functions be like f of n and g of n. We take two functions, a function f on input size n and the function g on input size n. We will take these two functions into consideration and we will see how can we explain all these terms. Okay, the first one which we will see in this lecture is big O. Okay, according to the definition of the book says the function, say f of n, is equal to the big O of the function g of n. ठीक है, अगर हमारे पास एक फंक्शन है f ऑफ n, वो बराबर होती है बिग O ऑफ g ऑफ n. ठीक है, if and only if there exists a positive constant. Okay, let that constant be c, and there exists an input, and not means the initial input from where we will start this, such that f of n is less than or equal to constant times g of n. ठीक है, for all n should be greater than or equal to n0. This is what book says, and I know it's very difficult to understand it this way, so let me make it easy and simpler for you. If we are having any algorithm, if we are having any program, if we are having any function, any statement, how can we represent that in terms of big O? First and foremost, we must understand, it's very difficult to understand it from this, right? Because what does this mean, that f of n is less than or equal to constant times g of n and all that? Now we should have some positive constants and all these. In a simpler manner, first understand it that way, you will understand it this way easily. According to me, I am saying big O is nothing. Big O is nothing but the maximum time, or the longest time an algorithm can take for completion of its execution. Isn't it easier? Big O is basically nothing. It is telling us how much maximum time your algorithm or your program or any programming statement would take, or how much time it is going to take in order to get completed, for the complete execution of that particular algorithm. That is big O. Big O only says how much maximum time your algorithm would take in order to execute its statements, in order to execute the whole program. That is what big O is all about. Okay, ओके, आई विल रिपीट इट. बिग ओ का मतलब है कि मेरा ये एल्गोरिथम, मेरा ये प्रोग्राम ज़्यादा से ज़्यादा कितना टाइम लेगा एग्जीक्यूट होने के लिए, उसी को हम बोलते हैं बिग ओ। ये टर्म हम तभी यूज़ करते हैं जब हमें मैक्सिमम टाइम देखना होता है। जैसे कि मैं आपको बोलूँगी, आपको मैंने एक असाइनमेंट दिया है और मैं आपको बोलूँगी टेल मी ज़्यादा से ज़्यादा कितने दिन लगेंगे आपको ये असाइनमेंट कंप्लीट करने के लिए। That means I am talking about the maximum time. Whenever you would be asked about the maximum time, the terminology, the symbol, the operation which you are going to use will be the big O sign, because big O only says the maximum time your algorithm would take in order to for the completion. That is the reason why let the function on input size n will be equal to big O of g of n. ठीक. Now if I will come towards the definition, it actually says I can only say if I'm having two functions f of n and g of n, and I want to say कि f of n बराबर है big O of g of n के, I can only say this if this function f of n is less than or equal to some constant times g of n. Okay, now this is a constant which is assumed for all n where n should be greater than or equal to n naught. Okay, this is what it actually means. Now see graphically, I would make it more easier. Say these are the inputs, and this time line shows a time. How many functions we consider? Two functions, f of n and g of n. Say for example, this is one function and this is another function, constant times g of n. Okay, constant times g of n. If we will analyze this, initially this f of n is greater than, that means this f of n is greater than or equal to at certain points constant times g of n, isn't it? Then it is here, it is greater than, here it is equal, then again it is greater than, then suddenly after certain input, that means at this point, or at this point, till this point f of n is greater than this, but at by giving the input this, after that, say for example, let here n is equal to 1, here n is equal to 2, here n is equal to 3, here n is equal to 4, here n is equal to 5, and here n is equal to 6. When I am giving 6 input for this particular function or for any algorithm, I am seeing after giving 6 or any other number greater than 6, this function will always be greater than this function. That means the growth rate of this, let me write it on here. So I can say the growth rate of f of n will not be more than the growth rate of g of n after certain input, isn't it? So we can say, so the maximum time of this function f of n will not be greater than the time taken by this function g of n. So you can say the maximum time, the big O of f of n, will not be greater than this. It can be equal to this. This function can be executed up to this, but it cannot have value or gets executed more than this. Let me give you a simple example. Say for example, I am having two functions. Say for example, this function would take 5 seconds in order to get executed. Okay, this function can be executed in 6 seconds. You can execute the same function maybe in depending on the input, in 7 seconds, in 8 seconds, in 9 seconds. Say this c of n in 10 seconds, but it is not possible that you can execute this function in the 11th second. That's what it means. Okay, the growth rate of this function will be always lesser than this function. The maximum time of this function will always be, lesser than the maximum time of this function. so that we can say the growth rate of this function will always be lesser than this function. That is the reason why we say f of n should be less than or equal to some constant. When we multiple that constant with this function, this will be lesser. If this condition would get satisfied, okay, then and only then we can say that this function is equal to big O of g of n. Okay, let me give you a simple example so that you can understand it more. Say for example, let we have two functions. Let f of n 3n plus 2 and g of n be equal to say n. Okay, say n. In order to say that f of n is equal to big O of g of n, we have to check a condition. And what is that condition? That this f of n should be less than or equal to some constant times g of n. Okay, now this f of n is 3n plus 2, should be less than or equal to some constant times this g of n is n. You can write it as big O of n as well. There is no issue in that. Okay, so this is what we have to prove. Fine, we know that this n is our input, and this input you can take from anything. I told you in the last time you can have 0 or more inputs. So if you will take 0, the term will be 0, this will be 2, and this whole term will be equal to 0, right? So we are not going to get any conclusions from here. So you always have to remember, for this, as I told you, your initial input size should be always greater than or equal to 1. Okay, it should not be less than 1. Okay, now see, say let your constant be equal to 1 and your n be equal to 1. We took only one input, that means say one element. Okay, and if I will multiply this with a 1 by taking 1 as a constant, can we justify this? Let me try. 3 into 1 plus 2 will be less than or equal to 1 into 1. 3 plus 2 is less than or equal to 1. 5 is less than or equal to 1. No, that means we have to do some other thing. So similarly, if you will increase the input size and you will increase the constants, it is not going to change up to this. Like in this case, we are clearly seeing that f of 5 is not less than this, 5 is greater than this. Like in this graph, as I said, there are few inputs where you can see that this function is greater than this, but big O says that this function should not be its execution time should be less than this. So we have to in order to do that, in order to make the execution time of this function lesser than this, we are multiplying it with some constant. Okay, now if you will take, let constant be equal to 4 and n be equal to 2. So 3 times 2 plus 2 is less than or equal to constant times big O of 4. So this is 6 plus 2 is less than or equal to 4 into 4. 6 plus 2 is 8, is less than or equal to 16. Right? Okay, this n is 2. 4, 2 is 8. So 8 is less than or equal to 8. Yes, 8 is equal to 8. Isn't it? Now, taking constant equal to 4 and by increasing this input size, this function will be always equal to this function. So, let me write it over here so that you will understand it more. So, I can say yes, 3n plus 2 is equal to big O of n, or f of n in this particular example is equal to big O of g of n when f of n, so you know that we have to check the condition, when we take constant equal to 4 and n equal to 2, then and only then we can say this is equal to this. So this is true. I will okay, on the same example, let c is equal to 4 and n is equal to 10. It will be always, the f of n will be always lesser than this. So 3 of n plus 2 is less than or equal to constant times n. So n is 10, so 3 into 10 plus 2 is less than or equal to 4 into 10. So this is 30 plus 2 is less than or equal to 40. So this is 32 is less than or equal to 40. Taking c is equal to 4, okay, taking a constant equal to 4, okay, and now take any input size starting from 2 or starting from 1, or if you will take constant equal to 5 and then n is equal to 1, this is always going to be proved. So we can say this function is less than or equal to this, and we can say yes, 3 of n is equal to big O of n. Okay, so this is what basically big O of n is all about. Big O of n is nothing, but it only tells us how much maximum time your algorithm would require or your algorithm would take in order to get executed completely. I will give you a few examples. Try it at home. This is your homework. 3n plus 3 is equal to big O of n. Prove this. 100n plus 6 is equal to big O of n. 10n square plus 4n plus 2 is equal to big O of n square. And in the next class we will see what is big omega and what's big theta of it. Thank you so much. Have a nice day.